Hello, welcome to the Center of Math's Advanced Knowledge Problem of the Week. In this week's problem, we're evaluating the integral e to the negative x squared dx from negative infinity to infinity. So the first thing to talk about is that when we evaluate this with respect to x, it's the same as if we evaluate e to the negative y squared with respect to y over the same limits. So that means that if we name those two things, we set them equal to each other and name them. We'll do that now. So we name those, we call it I. And then if we take the, if we can multiply these by each other, and that's also equal to the double integral, that is equal to I squared. So then I squared is equal to the double integral of e to the negative x squared minus y squared dx dy. So what's important to talk about is that if we're talking about the change in x times the change in y, what we're talking about is the change in area. So this is the same way of saying dA, the change in area. And if we look at our limits of integration, we're talking about from negative infinity to infinity in the x direction, from negative infinity to infinity in the y direction. So we're talking about evaluating this integral over the entire xy plane. So we're talking about the entire xy plane here. And the reason that's important is because although right now the integral looks particularly difficult, if we switch this into polar coordinates, which is what we're going to do, it will become relatively simple. So let's talk about polar coordinates. Negative x squared minus y squared is equal to negative r squared. And then in polar coordinates, dx dy, or dA, is described by r dr d theta. So we'll convert that right now. So this is the same as e to the negative r squared r dr d theta. And I left the limits of integration blank because we have to make sure that when we switch into polar coordinates, we're talking about limits of integration that describe the same space. So this first problem, we know that we're talking about the entire xy plane. So something that describes the entire xy plane in polar coordinates is when the radius goes from 0 all the way to infinity. It reaches all the way out. And then we're talking about a theta that describes the entire xy plane. So that's 0 to 2 pi. So it goes all the way out, and then it goes all the way around in a big, infinitely large circle. So that's the entire xy plane. So we're taking the integral from 0 to infinity with respect to r, and 0 to 2 pi with respect to theta. And then what we want to do next is we're going to do u substitution. And I think that I will have u equal negative r squared. So u equals r squared, then du equals negative 2 r dr. And then you just solve to get negative 1/2 du equals r dr. And we have r dr right here in our integral, so we can sub it out. We can sub that out for negative 1/2 du. And then we want to change our limits of integration to in terms of u as well. And when you do that, you'll get the following. So you'll get that inside integral, this one right here, ends up equaling negative 1, and then times negative 1/2 is going to be just 1/2 pulled out here to the outside of the integral. And then this one is also pretty easy to do by looking at it. The integral of 1 is going to be, or the integral of this integrand is going to be just theta. So then 2 pi minus 0 is equal to 2 pi times 1/2 is equal to pi. Now we have to remember that pi is the value that we get from evaluating the double integral, which is equal to I squared. But we're asked to evaluate the integral that is equal to I. So then we have to take the square root of I squared equals I, so the square root of pi. And so our final answer is the square root of pi. So that concludes this week's Advanced Knowledge Problem. Make sure you check us out on Facebook and Twitter, and take a look at our blog at centerofmath.org. Thank you.